Good morning. How's everyone today? All right, so we're going to go ahead and get started. A couple housekeeping things for CCA and CEU credits. We will be passing something out towards the end for you to scan and fill out a very quick evaluation survey. Put your license information in and we'll then submit it all for you so that you don't have to worry about that. So we'll give you more instructions at the end of this morning session. We're thankful that you all made it out today. We have a good turnout, a good group of scouts and growers here. So we're thankful that you guys made the time to come out and join us. Really looking forward to the discussion that we're going to have towards the end and after lunch about some of the BMP research, nutrient management research that we'll be doing. And we'll have a little bit of intro to that during our morning sessions. A couple of other things just so you know about housekeeping. One is bathrooms. The men's is to the left as you go out, the women's is to the right. There is some fresh creamer out there that I forgot to put out. So if you want some fresh stuff as opposed to the dry, that's out there. Unfortunately, we're going to have a couple of presentations that are going to be via Zoom because we had COVID kind of outbreak at the Tropical Research and Extension Center down in Homestead. So one of our faculty members who's presenting ended up testing positive for COVID. So he's going to be sharing with us via Zoom. We also had one of our growers from down there send an email at 4 this morning saying he wasn't going to be able to make it because he also has COVID. So unfortunately, but otherwise, we'll hopefully be able to have, obviously it's a little bit easier to have discussion for the in-person parts of it. So we'll kind of have some of that towards the beginning and then get to move on. We'd really like feedback today as much as possible. For some of our presenters are going to be specifically asking questions from you all. As you all know, that snap beans is not something that UF has really engaged with a whole lot in recent years. And so we've kind of gotten to do that through this new invasive pest Asian bean thrips. And we like to do that more. We like to be able to support the industry well. So appreciate feedback from all of you as we move forward. I think that's all the housekeeping things. So, all right, first up is going to be Anna Mézáros. She is the Palm Beach County Commercial Vegetable Extension Agent, and she's going to be talking about Asian bean thrips review and update.
Thank you, Craig. All right, what?
All right, one more thing. This is a little bit more for the presenters. Those online, just try to keep to your time. Those that are here in person, we have a light at the front. When you have 2 minutes left, it's going to turn green. When you have 1 minute left, it's going to turn yellow. And when your time is up, it's going to turn red. And you basically need to say thank you and move off so that we can stay on time, be ready for our steak lunch at noon, and be able to get out of here after our discussion afterwards. So hopefully that'll keep us all on time. It worked well at the tomato conference that we had last year. So hoping to do that again and move forward. Thanks.
Seriously, Craig? I feel like again in an intersection or something. I'm gonna get kicked out. Where I am? All right, everybody woke up. We had good coffee and everything. So welcome everybody. This is our first meeting, like Craig mentioned here, about snap beans. Never had it before. So I just wanted to welcome here everybody at the Evergreen Research and Education Center. Again, my name is Anna Mézáros. I'm the relatively new commercial vegetable extension agent here in Palm Beach County. And just heads up, who has not heard about Asian bean thrips yet? Okay, so I guess you are doing a great job and I can just go home. So anyway, I will keep this brief. Probably you know more about it than I do. I will give you a quick review and then give some updates what we are doing here as far as research and extension. So I'm glad that we have representation from all the bean growing regions, Miami-Dade County, Palm Beach County, and the Southwest Florida region. So most of you know that officially this Asian bean thrips was detected back in 2020, early 2020 near Homestead in Miami-Dade County, where significant damage was reported in a snap bean field by scouts of Glades crop care. You can see all the damage what these thrips can cause on early stage beans. And so we collected specimens, they collected specimens, and then send it to UF, IFAS, and then also FDAX, and then finally they identified it as the Megalothrips uscitatus, the Asian bean thrips. And you can see those big, large adults on the back of the bean leaves. So when all these things happened, the pest alert was sent out to stakeholders, to you with detailed information, and also some preliminary surveys were initiated. So just quickly how this pest looks like. And let me see, I have a nice little video here if I can launch. I didn't do this, it's not me, but it's kind of cool. So the female Megalothrips in the females in the Megalothrips genus, they are usually black and have these stripes on the back that you can see down here. And the males are usually smaller than the females and then have a lighter brown color. And the young larvae are pale yellow like other thrips, but the late install larvae, you can see that it's kind of reddish. So this is when you see this in the field, you are already in big trouble, you know that. And also what I used to use when I was kind of identifying these thrips, this is up here, this third segment of the antennae is usually lighter. So that's a giveaway. When you see a big thrips, a larger black thrips on beans, you are almost sure that you have Asian bean thrips on your bean. Oops, again, oops. And so other similar looking darker thrips you can find on other leguminous plants. That's Franklina insularis, but it has only one little stripe on the back that you can see it on the picture. And luckily you don't find that on beans. So like I said, again, if you have a larger black beans, it's probably what you have in Asian bean thrips. So you can see here, as I showed before, the damage. The tricky things with these Asian bean thrips that they attack all the growth stage of the beans, and they can come in really early, which is really different compared to the other thrips species. So we did the assessment, and then we heard from growers and consultants that 2020 it was really bad. And growers even reported 30% loss in snap bean due to Asian bean thrips primarily, and including some thrips palmi and bispinosa injury too. But that was really bad. Nobody want to talk about it anymore because it hit us really bad, especially down in Homestead. So just remember, this was the first record for North America. No insecticide efficacy data was done before at that time. We had some limited data on a Megalothrips distalis, which is showed up in North Florida, but we didn't know, we didn't have anything. So preliminary research had to be conducted in labs and in the fields to test insecticide for Asian bean thrips. And also we had to look at potential roles for the host plants in insecticide susceptibility. So these are quickly just the bioassays that Bruno Rosito did up in at the Golf Course Research and Education Center with Hugh Smith. And what they found basically, they collected thrips, adult thrips from different locations, from different host plants, and they tested all these insecticides. But the bottom line is what they found, that all these Lanate, Acel, Radiant, Agrimac, Exura, they did a pretty good control, almost 100% control. They caused 100% mortality on Asian bean thrips adults. And what's most important in the whole thing is that all the pyrethroid didn't do anything. So really, that's probably the main message, that don't apply pyrethroids because it won't do anything with your beans. So with your Asian bean thrips. The good thing is that we kind of confirmed this in the field. We set up a trial here in Loxahatchee, and we would like to thank to the grower, because that's very much the only trial, large field trial, that we were able to put out up here in Palm Beach County. And we more or less confirmed what the bioassays said, that pyrethroids just didn't work. And then we also saw some trend that radiant and also lenite would potentially work to control the Asian bean thrips. All right, so what we did with all these data and informations, Craig sends out all these updates and pretty regularly, almost monthly, and he created this website with all the information, with all the meeting presentations, publication, Thrips ID guides, more detail that I just talked about. And he put out all the scouting reports. So this is really a nice collaboration between him and all the crop consultants. So if you growers are here, thank your crop consultants, because without them, this wouldn't be able to happen. So this is what usually probably you can see on the with the scouting reports, weekly scouting reports. You have data down from Homestead and the Henry and Palm Beach County regions too. So this is just a little summary what happened before and what's happening today, because the populations are down. If you look at, that 2019-20 was horrible. 2021 production season was horrible too. But something happened this year, and because even back in January we didn't have anything, almost nothing here up in these counties, except this little, again, Homestead area. And then if we move 1 month ahead, we compare 2021 with 2022, again, almost basically nothing. So either we did a really good job, or these thrips were scared of us, I don't know, but nobody really knows. I talked to Matt Bardin and then a few crop consultants, and we tried to figure out and put the puzzles together. So this is gonna be probably the next step, to figure out what's going on. When you have low numbers, why you have low numbers? When you have high numbers, why you have high numbers? So just overall, yeah, we need to keep in mind that this is still a threat. Even if up here, the numbers were still low. Homestead lately had some trouble, not just on snap beans, but over on peas too. And I just talked to Lauren a little bit. He could even tell you more about this. So just keep it in mind. Early detection is important, and yeah, again, just to compare the 2 years, you can just see that how different it was. These were the percent of blue sticky traps in Southwest Florida, and how the numbers were way lower compared to the previous year. Again, same thing here. So why these infestation levels were lower this year, we don't know. We can kind of speculate, but we need to keep an eye on these things here. All these wild hosts, they might play a major role. So this is something that we need to look at, and do some more research and more trapping data. So just consider alternative weed host removal and control. I don't tell you do it, just think about it. And then think about extend follow periods between planting. And so, like I said, more research needs to be conducted on all these, and probably need to verify this threshold, because we think that it's okay, but just to make sure. So our goal is still keep continuing this collaborative effort between growers, scouts, and state and taxonomists and all these smart people, and still provide timely information to assist producer, crop consultants, and extension agents, and to all of us, because we all work on this together. And I would like to thank everybody, and especially the crop consultants, because they are a huge help for us to get this information out every month. And I know I'm a little, maybe I have a bunch of time left, but if you would like to ask any questions or comment on it about the situation, what happened this year and what happened before, I think we have still a few minutes. So, thank you. Anybody, any questions? I think we have, or just comments. Thank you.
In climate or weather patterns make an impact on the distribution and on how much there is.
This is a tropical species, so weather and temperature probably plays a role. What we talked about that last year we had a cold snap too, about the same time as this year, and they didn't do much. But this is definitely that we can look at. We need to look at just sample experiments, you know, about the temperature range, what this species can handle basically, because that might be our limit up north. I mean, we are now, it's Palm Beach County, I think the northest limit, Martin County. So we never seen anything north of that. So that's why it's important to keep monitoring the situation. But it's an easy lab assay. Put them in different temperatures and look at survival.
Any associations with red nose virus?
Who I wish Charlie or Madeline Mellingers would be here, because I think they looked at this, but I don't think so. At the early stage, they looked at this and they jumped on if there is any transmission or any vector issue with this species, but not aside, no.
Lauren, you want to comment on that? If you see it more than us up here?
No.
Yes.
No, we have a lot of problems. We rarely see
If you, no, that's yeah. He's the one down in Homestead who knows way more than any of us here.
We're under heavy pressure right now, but they're not dominant species at home. It's pleasant flower and palm. So, that makes a difference, but we have at least 3 or 4 species at home.
Yeah, I remember at the very beginning, Asian bean thrips outcompeted the other ones, the palmy at the very beginning, and then maybe we are seeing a switch lately. So this is something that we need to look at. You know, it's 3 years, and then we'll see what's going to happen next year. Anybody else? Thank you.
All right, so next up, we have Dr. Daksina from the Tropical Research and Education Center. He's gonna be talking about comparative abundance of Asian bean thrips, melon thrips, and Florida flower thrips on 5 bean cultivars in Homestead.
Thank you, Craig. Thank you, everybody. I'm sorry I could not be with you guys. I really miss you this meeting. But anyway, I'm glad to present my information that I collected from my research. Today, I'll be talking about the comparative abundance of different thrips species in 5 bean cultivars. The thrips I'll be talking about, they are Asian bean thrips, melon thrips, Florida flower thrips, western flower thrips, and common blossom thrips. These thrips are polyphagous and they can be found on all these bean varieties. Asian bean thrips, it arrived in 2019, last part, December, sometimes November, December. Melon thrips arrived in 1990. Both thrips are from Asia. They have a worldwide distribution. You can see here, the first slide, it shows the melon thrips distribution, and the second figure shows Asian bean thrips distribution. This shows a chronological pattern of Asian bean thrips damage on or injury on snap beans and other beans, but this slide is specifically from the snap beans. This is the first one. You can see them at the center of the plant, the small leaf they are there, then it goes forward, then goes forward. At the end, this is the flowering stage where the population really increases, and you can see some damage. The last slide shows when population abundance is high, you can have some damage on your pods. This is melon thrips damage. Melon thrips damage is mostly you can see on the underneath of the leaf, but their damage is mainly feeding damage. You can see when population is high, that is the first slide shows complete defoliation of the field. Varieties I will talk about is snap beans, two varieties, Opus and Miranda, kidney beans, hyacinth bean, navy beans, and black-eyed peas. These are the images of those beans. The last slide shows my field study. The study was conducted in TREC research field. They were arranged in a randomized complete block design, replicated 6 times. The field was planted on February 3rd in 2022. We evaluated those crops 6 times during their growth period. We collected 10 leaves and 10 flowers from each plot, 1 leaf and 1 flower from each plant in a randomized way. Then we put them in a container. We wash them with alcohol. You can see the next slide figure. It shows how we are processing this sample. Mainly we wash them with alcohol and we then separated them. This is the first result slide. It shows the abundance of Asian bean thrips and all other thrips. This is, you can see that the first one is the highest number we observed in hyacinth bean. And this number is irrespective of any species, just total number I collected, followed by your black-eyed peas. Here, if you look at the y-axis, you can see the number is from 0 to 250, which is very important to notice. And then you can see the most of the thrips are on the hyacinth bean, and other beans you see some, but not as high as hyacinth bean. This shows, now question is, we see all these thrips, who are they? Are they one species or different species? And here I'm showing bispinosa, which is Florida flower thrips on different cultivars. Again, you can see here that this is hyacinth bean, the number is highest, and here the y-axis shows 0 to 250. Here per 10 leaf samples in general, we collected 225 thrips. Two things here, this side, the blue bar is the flower sample data and the red bar is the leaf sample data. You can see very small number in the leaf, but it is also very important for making any management decision. This shows occidentalis. Occidentalis, here the y-axis shows 0 to 1.4. Number is very low. Okay, then comes Asian bean thrips. Asian bean thrips was the highest, abundance was the highest on your, oh God, on the black-eyed peas, followed by other navy beans and hyacinth bean, the highest number. And that number was 31 per sample, per 10 leaf samples. Again, on the leaf sample, you see very low number. I put the number here. You can see that there. Now, Thrips palm is our another major species here. And Thrips palmi population was the highest on Opus bean, followed by kidney bean and navy bean. We have per 10 leaf samples, we found 12.48, that means 13 per 10 leaf samples. In the previous slide, you have seen that most of the thrips were in the flower sample, but in case of Thrips palmi, the abundance is high on the leaf samples. It is a foliage feeder, and that's why it is more abundant on the leaf than on the flower. Now, abundance in different growth stages. These growth stages, we collected them 2, 3 weeks, 4 weeks, 5 weeks, 6 weeks, 7 weeks, and 8 weeks after planting. And you can see I divided them into 2 phases. The first 3 bars represent the vegetative phase, and the last 3 bars represent the reproductive phase. Reproductive phase, you are seeing all the flowers. Vegetative phase, mostly there is no flower. And you can see that all thrips, this is again irrespective of any species, all thrips are less when the plant is in the vegetative phase. Thrips population started increasing when it moves to the reproductive phase. Another thing is to mark here that thrips population, they always get increased higher number, it becomes more and more abundant as the season progressed, which is after 5 weeks, 4 to 5 weeks. Here is the flower sample. Here, again, this part in the reproductive phase, we did not get any flower up to this, in this vegetative phase, so we could not collect any flower. Here, these are the flower samples data, which shows the number of thrips in snap beans. This is a kidney bean. Leaf samples, the number is again low at the beginning. Plant did not have any flower. Once in the flower phase, you can see the higher number on the leaf 2. In the flower, this is again, these are the number in flowers of kidney beans. Number went high from 76.29 per flower samples, and these are all leaves together. So that's the slides, end of the slides. So I like to conclude by saying that Florida flower thrips was the most abundant on various cultivars. Asian bean thrips was more abundant on hyacinth bean, followed by black-eyed peas than any other bean cultivars. Population abundance of all thrips was higher on flower samples than leaf samples, except melon thrips. Thrips population abundance is higher in each cultivar at the reproductive phase than at the vegetative phase. Thrips infestation starts at 3 weeks after planting and continues until harvest. Thank you. I'd like to acknowledge these people. With that, I thank you all. If there is any question, we'll be glad to answer quickly.
Thank you, Dak. We do not have time for questions. We're actually going to keep moving on, but we appreciate your presentation, sharing with us from Homestead.
Thank you. Thank you.
Next up, we have Dr. Shouan Zhang. He, again, is not able to join us because of COVID happening down at the Tropical Research and Education Center in Homestead. He's going to be talking about management of Rhizoctonia in snap beans by biological product.
Okay, good morning, everyone. Thank you, Craig and Anna, for organizing this important snap bean meeting. So I'm very happy to see some friends in the audience. I'm sorry, I'm not able to be there today. So I'm going to talk about the management of Rhizoctonia in snap bean by some biological products. So snap bean production in Florida is important. We all know in the ridge and also the value. In 2020, Florida harvested on 58,000 acres, valued at about $69 million US. And in Florida, pretty much the snapping pretty much grown in South Florida, including Miami-Dade, Hendry, and Palm Beach counties, and also in another region in Elytra County. So we know a lot of disease on snapping, like foliar disease, including anthracnose, etinary rust, powder mildew, even white mold, so and some others, and also some bacterial disease like halo blight. Sometimes, a lot of times we saw here in Homestead in winter and early spring, and also another one is common bacterial blight, and several important viral disease such as being golden mosaic virus, and also red note a few years ago we got this. So also we have seen a lot of root disease on snappings, such as PFM disease, root knot caused by fusarium, root knot caused by Rhizoctonia, which I'm going to talk about after this. Here, Rhizoctonia disease is one of the most economically important root disease on beans. So that disease caused by a fungus, Rhizoctonia solana. We can see the early infection after seeding caused dying off, and also during the plant development, you can see the symptoms of root knot. In Florida, usually this disease causes with over or around 10% of stand loss, and the most severe case reported up to 75%. That's some pictures I took from our trial. That's the one on the left. Like you see a lot of plants missing, and that's in the field plot you saw at the emergence of the plants. A lot of plants are just missing. Yeah, that's some symptoms I took from the trials. You see the in the middle, top middle, that's a kind of damping off when the plants are small. The corner of top right, that's the adult plant. You can see a lot of layers, kind of a brown or red around the soil line. And in the field, you see the same thing. And the plants, they keep dying because of the infection during the growing. So basically the fungus just survived as mycelium or sclerotia between seasons in plant debris, in soil, and also in some perennial plants. They can be carried on or within the bean seed and spread debris in infested soil by wind, by splash rain, irrigation water, and even human practices. The fungus got on plants, they can penetrate the cuticle and epidermis of the plants by directly by infection packs, a structure of the pathogen after they land. So the fungal hive, they can enter through a natural opening and wounds. Some other factors can affect the Rhizoctonia disease, like you see the temperatures, the disease most severe when temperatures are cool, like about 65 to or 60 to 65 degrees. So I have seen more Rhizoctonia problems in Homestead area after cold fronts many times here. And the other thing is the soil compaction can increase the Rhizoctonia disease. And also seems like the young seedlings and plants like younger than 4 weeks usually more susceptible to this disease. So let's talk about the management. once the field got infected, it is very difficult to control because this pathogen has a wide host range. So for the control, the cultural practices, you can think, select tolerant cultivars if available or possible. Use disease-free quality seed that can germinate quickly. And if possible, you can rotate with non-host crops such as corn to avoid the legume crops and the cover crops before planting, and also plow and snap beans after the season. For some double crop systems, wait enough time after disking the previous crop to allow green matter to decompose. Also, plant when soil temperatures are warmer for rapid germination, and avoid deep seeding and control soil insects and nematodes, because these insects or nematodes, they can provide the entrance for the pathogen getting into the plants. We have several fungicides registered on beans to control Rhizoctonia disease, primarily those containing azoxystrobin, like Cultivars, like Frey, like Dynasty, and a lot of more. And also there are many byproducts such as actinovate, root shade, and a lot of. Here, I'm going to just present you the result we got from a field trial conducted here at TREC in 2021. Basically, we tested the biological products Holler and the Thea from egg biome. Holler is Pseudomonas product registered in Florida on legume crops like broad beans, peas, but yeah, it's not yet. It's still under EPA review. I think somebody told me they anticipated this product to be registered or approved by EPA in May this year, but I haven't heard anything yet. The other one, biological product is SP2700, also they call Ninja. This one from Seepage. It is a biochemical product extracted from soil bacteria, and they have they got somebody collaborators work with them to prove the mode of action is induced resistance in the plants against different pathogens like plant virus, powdery mildew, and some soil-borne disease. So that's the information of the field trials we did in Homestead. We used a snapping Desperado. We planted on November 2nd, 2021. We inoculated the soil with autoclaved wheat seed infested with the pathogen Rhizoctonia solania and spread uniformly in the furrows at 1 gram per feet. Then for treatment, here the treatment, we totally have 6 treatments. And for the first 3 treatments, we use the untreated seed. And the first treatment, the number 1, that's untreated seed, CK1. The second treatment 2, we spray the whole at 5 pounds per acre on seed before at planting, and also after emergence, we continue this treatment at foliar spray weekly. Treatment 3, that's here at 3 pounds per acre, also did the seed spray on seed, and also after emergence, we spray weekly at the same rate. So treatments 4, 5, 6, we use the commercially treated seed. That's from I think it's Syngenta or other collaborator. I forgot. Sorry now. And the seed is usually treated with mefenoxam, thyrine, streptomycin, and some others. We didn't do any spray on seed with this treatment like number 4 SP 2700 at 11 ounce per acre. We just did foliar spray weekly after emergence, and also treatment number 5 Cultivars plus Rhizoctonia as a fungicide standard. And number 6 is the treated, only the commercial seed. So CK2 we call it. Okay, so that's the result we got. That's the plant stand after emergence. You can see the whole significant, the whole just spread on seed at planting significantly increased plant stand compared to treatment number 1, CK1. That's all these 3 all on treated seed. Okay. So whole showed very significant effect compared to this one, CK1. And all these treatments 4, 5, 6, they are commercially treated seed, but the 4 or 5, we didn't do any seed spray at planting. But you can see the commercial seed are very important for control of this disease. You can see they plant 60%, but for untreated treatment 1, only like 12, 13%. So that's some field pictures I took, like untreated seed control on the left. Very few plants you can see because we inoculated the soil heavily with the pathogen. And the treatment number 2, that's whole spread on seed at planting in furrow. You can see much better compared to CK, the control. So that's a treated seed on the left and the commercial seed only on the right. You can see the big difference. And here I just show you the result we got for the effect of the treatment on the disease development. And the top 3 treatment 1, 2, 3, you can see the Rhizoctonia disease incidence much higher, and the lower 3 all used commercial seed. So treatment 1 and treated control, that's the highest disease we got. And the treatment 6, that's commercial seed only. You can see lower disease, much lower compared to untreated seed. Treatment 2, that's whole, only spread on seed. You can see the treatment reduced significantly to the treatment number 4, the SP 2700 as foliar spray after emergence did pretty good, even compared to the commercial seed control. And of course, you know, this one is a fungicide standard. Really was the best one in this trial.
Shouan, you have 30 seconds to wrap it up.
Oh, okay. So final disease, the same thing. You can see whole good, SP is 2700 good, and also the yield. You know, that's the same thing. Yield increase by these 2. That's some pictures. You can see it's good always on right. That's the standard chemical. So that's a take-home message. I said already, I don't want to repeat. And I want to thank people who work with me and also the TREC field crew. And disclaimer, mention of these trade names doesn't constitute an endorsement by university, only for purpose of providing specific information. Okay, that's my contact information. If you have any questions, you can send me email or call me. Thank you.
Thank you, Shouan.
Thank you.
Great, thank you for your presentation. All righty. Next up, we have Dr. Katia Xavier from here, the Everglades Research and Education Center. She is a new plant pathologist here. She's been here just for 3 months. She's going to be talking about identification and management of some snap bean diseases occurring in South Florida.
Hi, I think I'll get started. Oh, the slides are up there, but yeah, I would like to thank Anna and Craig for the opportunity to be here today. As Craig said, I just started 3 months ago, but it has been a great 3 months. I'm learning a lot. I started towards the end of the vegetable season, so that was incredible. All the disease that I got to see, the production systems that, thank you. The production systems that they have here for the different crops. And all I have to say is like, thank you for the opportunity, you know, to be at this position today. It's like my dream job, and I'll try to make the best of it. And today I will be talking about identification and management of snap bean disease in Florida. And first of all, I'd like to ask your help, because since I'm new, I'm trying to identify areas to study. And I want to do my research based on the problems that you guys have, because I want to help you to address those problems. And of course, to produce better and higher yields with less disease. So I'd like to ask your help to fill out this survey. If possible, I just have three questions there. One is, I'm asking you to rank the diseases in order of importance for you. Either if you're a grower, a crop consultant, or a professor, and you have seen diseases in here and you think they are important. So please help me. If there are some that I did not list in here, you can always add a note or others. And also for those diseases that you guys use fungicides to spray to control those diseases, I would like to know if you have seen some fungicide resistance. And if you are spraying fungicides and they are not working for that specific disease, if you can please add the fungicide name there, because that's going to help me to do my research. And to start my talk, as another plant pathologist, right? We always like to show the disease triangle. That's a base principle for the plant pathologists. And in here, we have 3 factors for the disease to occur. And we need the interaction of those 3 factors to have a disease and to have an epidemic. So the first one would be the pathogen that has to be present, and it has to be virulent, able to infect those snap bean plants. And based on the compendium of bean diseases, there are 72 pathogens that can cause disease on beans. And based on the environmental factors for the disease to occur, okay, first, snap bean is a warm season crop, and it's produced here in the southeastern Florida from September to April. And I went to the phone weather data, and I did the average from the temperatures from September to April for last season. And the temperature ranges from 61 to 80 degrees. And the humidity goes from 77 to 88. And those temperatures and high humidity, that favors lots of pathogens that are present in here. And on top of that, we also have the irrigation system that most of the growers use here is the overhead irrigation system that also favors the disease. So, but as I said before, there are 72 pathogens that can cause disease on snap beans. Most of those pathogens are present here in Florida, but I wouldn't have time to talk about each one of them, right? So what I did was to talk to Dr. Reid. Dr. Reid was the plant pathologist here for 35 years. And I asked him, what are the major problems or major diseases that you have seen in the area. And then he gave me this list of 7 diseases that he considered to be the most important ones. And I'll talk a little bit about each of these diseases, and then I'll talk about management strategies towards the end of this presentation. So bean rust is the first one I'm talking about. This disease, as you can see, there is this leaf. I don't know. Wait. Does not work. All right. Thank you. Okay. For this one, you can see here on the leaf, there are these chlorotic spots, and inside of those spots, you can find some brown powder, and that's very characteristic for the rust. And this disease has been reported to cause losses up to 30% on the yield. And the ideal temperature for this disease, it's something between 63 and 72. And if you remember the slide before, those are the range of temperatures that we have here in this area from September to April. So that's a very important disease to consider here. And in terms of management strategies for this disease, one option would be to use resistant cultivars. And in the end of this presentation, I will show a table with the cultivars that I found on the vegetable production guide and the package of resistance that those cultivars bring. And there are some that are resistant or tolerant to this disease. So 2 examples would be the Soto and Coulter. And to control rust, another option is to do the chemical control, is to spray with fungicides. And I checked the vegetable production guide again to see which fungicides that are available, and this table is actually there. So if you want to take a closer look, it's just part of this table. This table is longer than this. And there are 6 modes of action of fungicides that you can use, and that's important because then you can do like rotation of those fungicides, and that's really important to avoid the pathogen to create resistance toward those fungicides. Another important disease is called the white mold. This disease starts, the symptoms start as a watery, soft rot at the base of the plant close to the soil line. And then the disease progresses upwards, and it can infect the leaves and the pods. And then this disease has that white cottony mycelium, as you can see on this picture here. And another thing that's important for this disease, to do the identification of this disease, is that this pathogen is able to produce some sclerotia. That's a resting structure that's going to make this pathogen survive on the soil. So with that, one of the management strategies for this disease is to plow the field to incorporate those sclerotias into the soil and kind of destroy it. And also flooding the fields is going to help to reduce that inoculum population. And another possibility for this disease in terms of management is to do chemical control. And there are 6 modes of action that can be used for this disease. And once again, I got it from this table is from the vegetable production guide. So if you want more details, you can go there. They have all the information about the rates that has to be used and everything in there. And the third disease I'm talking about is another one that produced this white mycelium. But this one is different because this one, the pathogen will form or produce its mycelium on the leaf surface. So if you try to brush it off, it does not get out. So it's a little bit different from the other ones because it's on the leaf surface. In terms of, and also this disease is favorable by severe cold and humid weather. And in terms of management strategies, it's recommended to use resistant varieties and also do cultural control. That would be crop rotation and plowing those infected debris into the soil. And this one, you also have the option to do the chemical control using fungicides. And there are 5 different modes of action for this disease. And now another one, this one does not produce the white mycelium, so it's a little bit different, but it's easier to do identification because even though it starts as tiny little lesions on the pods, you can see the disease will progress, and then you can find these zonate lesions. It's like a target lesion, look like a target, so it's easier to identify. And this disease occurs here in the southern part of Florida throughout the season, so that's important. And usually the plants get more susceptible to this disease if they are under certain stress, like if there is a mite attack or if the nutrients are, if there is a nutrient stress on those plants. So that's going to favor this disease. With that, some of the management strategies for this disease will be to avoid nutrient stress and also to control the mites or insects that are infect those plants. And in terms of chemical control, it's recommended to do 2 applications of fungicides. And those are the 2 fungicides that I found on the literature. So it's Quadris and Emister. Yeah, that's pretty much it for Alternaria pod spot. Now, another important disease, and I think it's important to show it here, it's caused by Pythium. And this disease also produces this white mycelium. I'll try to show it here. So it's like a cotton ball that you can see here. And you can see that on the leaves, on the pods, and close to the soil line. So this disease is important because, you know, the white mold that's caused by sclerotia, like the symptoms are similar, but the difference, I think the main difference is that for the white mold, you are going to find those sclerotia. That's like, it has like the bean size and it's like, has dark color. But in this case, Pythium does not cause that. So that's the main difference between those 2. And for the Pythium, the infected plants can wilt and die really quick. And another thing that's important about this disease is that there are no management strategies that are well developed for this disease, but of course, crop rotation always help, and incorporating that material into the soil, especially into the muck soils, because there are a lot of microorganisms that muck soil that can actually degrade it really fast. So that's important. Now I'll talk a little bit about the virus that cause disease on snap beans too. So these 2, I grouped them together because the symptoms are alike. So that's bean golden mosaic virus and bean common mosaic virus. So the symptoms, as you can see on that first picture on the top here, you can see that mosaic. That's that model between light and dark green, or dark green and yellow. And also the leaves kind of curl downward. So that helps for the identification of the disease. And the pre-bloom infection, it's going to cause several losses, and those losses can be up to 90%. And there are 2 vectors that will be transmitting each one of these disease. Whiteflies transmit the bean golden mosaic virus, and the aphids are transmitting the bean common mosaic virus. And because those are insects, which that means if the temperatures are higher, that's going to favor the insects, so they will have a higher population. And with that, you can have higher disease level in your field. So if the temperature is high and you start to see those insects, that means you have to control the insects, because then they will not bring in the virus to your plants. And it's also important to use certified seeds free of the pathogen. And another option here is to use host resistant. So there are some resistant varieties that are effective for this disease. And I'll be showing a table in a little bit of that. So another virus disease is the bean red node virus. This one is very important, I would say, in this area because, okay, let's talk about the symptoms first. If you see, those are the pods, and it causes like red necrotic spots on those pods, and also it causes symptoms on the leaves that look like that. And the vectors here are some species of Thrips. And I said this disease is important, this region, because in 2020, that was just a couple of years ago, there was a very bad outbreak here in this area, and some fields I saw on the literature that they had like 100% lost. They had to destroy the whole field because of this disease. In terms of management strategies to be used, I would recommend use certified seeds without the pathogen, and then control the insect vectors. It's important too. And in here, I think it's important to point out that Thrips can become resistant to those insecticides really quick. So it's important to do a rotation of the insecticides too. Now, here an overall assessment of the management strategies to use for snap bean disease in South Florida. So I would say the three most important, and based on my talk when I was talking about all those diseases, you can see I always mention something about cultural practices, chemical control, and host resistance. So in terms of cultural practices, I would like to emphasize how important it is to do crop rotation with non-host crops for that specific disease that you had problem, and also to buy some certified seeds that are free of the pathogen, especially for the ones that cause those viral diseases. That's really important. In terms of chemical control, it's important to control. So 4 out of the 7 diseases I showed here, they can be controlled with fungicides, right? And also the ones that are virus disease, we can control the insects. So we have to keep that in mind, that chemical control is important for snap bean disease. So it's also important to rotate those mode of actions so you don't create resistance to that pathogen population or insect population. And always read the label before you apply those fungicides or insecticides. They bring all the information that you need in there. That's really, really important. In terms of host resistance, what I did was to go to the vegetable production guide. They have chapter 11, that's legume production. And they have this table where they put the name of the varieties that are recommended for this region. So I checked each of those varieties to see if they would have some resistance to those diseases that I was talking about. And I summarized that information here on this table. In the first column, I put the variety name. And then here, if it has like resistance against virus, against fungi or bacteria, and also some of the varieties have like some tolerance to heat stress. And I put it all here. So you can see overall, all the varieties have some degree of resistance against the bean common mosaicovirus. And some of them you can see there is some high resistance to rust pathogen, this variety, the Soto, some other ones here that also have some resistance to this fungi disease, and also some that has resistance to bacterial disease. Dr. Reid told me that bacterial disease are not really important here. Like he would see it here and there, but was not very consistent across all the fields. And that's why I did not add that during my presentation. But if you do have problems with bacteria in your field, you can consider to use some of those varieties. So in summary, for this presentation in South Florida, diseases are mainly caused by fungi and viruses. And those are, as I said, the most important problems in here. And the disease management depends first on the correct identification of the pathogen. As I showed, I think 3 out of 4 fungal diseases, they have that white mycelium, so we have to be able to identify which one is which to do the proper control. And overall, an integrated management approach, including both cultural, chemical controls, as well as the use of host resistance. It's important, should be adopted to reduce the impact of the disease on the snap bean production here in this region. With that, thank you again for the opportunity to be here. And if you have questions, I think we have a couple of minutes because I didn't see that light coming on, so I think we have time.
Thanks, Katia. All right, so next up, we're going to have our weed management for snap bean talks, and we're going to have both Dr. Calvin Odero from here at Everglades Research and Education Center, as well as Ramdas Kanissery from SWFREC are going to share with us now.
Okay, good morning. I'm Calvin Odero. I'm based here at the EREC. I'm an extension weed specialist, and I do work on several crops, including vegetables. And today I'm going to give a very general talk about weed management in snap beans. I know snap beans has been grown a lot here, mostly on mark soils, but in the recent past few years, I've not really been seeing much. I think most of it has gone more into more of sandy soils or the mineral soils, mostly in places like in Henry County. I think there's still a couple of places here in Palm Beach County where they still have snap beans. So snap beans is a very short season crop. Usually, less than about 60 days or close to 60 days by the time you harvest it. And it is very sensitive to weed competition, like several other crops. And when you don't do a very good job in managing weeds in your snap bean crops, then there are high chances that it will greatly impact your yield and quality of the crop. So I put a couple of slides here that show a list of some of the more common some of the common weeds that are associated with snap beans. And I decided to put pictures of seedlings because when you want to get a good job in controlling your weeds, I mean, most of the control you want to know what the seedlings look like. You don't want to go out and control your weeds when they're already big and flowering and producing seeds. So one key thing that you need to know is to correctly identify these weeds when they're small. So spiny amaranth, one of the amaranthus species, I think it's common here on mark soils, but I'm pretty sure I've seen it on some of our more sandier soils. Smooth pigweed, it's not so common on mark soils, but you'll find a lot of it in some of the more sandier soils. Common lamb squatters, for those who grow the crop here on mark, I mean, there are lots of it. And I think one big problem with snap beans now that I've had is with some of the nightshade species. American black nightshade is very problematic. There are other nightshade species that are associated with bean production in other regions, like hairy nightshade and so forth, but nightshades are very prevalent in a lot of bean production systems. And then we have common ragweed, which I think in most of our region here, you'll find it, and common pastline. And all these weeds, their level of impact on your snap bean will be major to moderate depending on how the control measures that you take. And then next year, I put there's another amaranth. It's called livid amaranth. It's kind of low growing, so its impact on yield will not be as great as what you'd see with some of the other pigweeds or the amaranths. Then there is a weed here called ragweed parthenium. It's very common here in our area on mark soils. Mostly you see it along canals and ditch banks, but of late, I mean, it started encroaching into most of our crops. For people in Homestead, it's one of the common weeds there, I think, in their bean production system. They probably have a lot of it. And one thing with this weed species, it's common in our area because it's glyphosate resistant. So when people go in and control weeds along ditches or canals, the only thing you get left is usually ragweed parthenium. And then there are two nutsedge species that are also associated with snap beans, the yellow nutsedge and the purple nutsedge. And I didn't put pictures here showing the flowers because if you want to identify the two species, one of the easiest ways is to look at the leaf tip. The one for yellow nutsedge is very long and pointed. The one for purple nutsedge is kind of more abrupt, so it's not very pointed. And another easy way to tell the difference between the two is to go out to the field and try and pull them out. If the tubers are connected in chains, then that means it's a purple nutsedge. And if you pull it out and there's just one tuber at the base of the plant, that's a yellow nutsedge. So that's the easiest way to tell the difference between the two before they flower. Because when they're up their inflorescence, the yellow will have a yellow inflorescence, and the purple, the inflorescence will be purple, and that's where the names come from. And then for grasses, these are some of the common grasses that we see here on our organic soil, but I'm pretty sure in some of the more sandier soils, you will also come across them. We got fall panicum, some of the crab grasses, goose grass, field sandbar, mostly on some of our more sandy soils. That's why even the picture I took here, it's on a sandy soil field. Crowfoot grass, I drove about earlier this week on some of the bean fields and in Henry County, and I saw quite a bit of these. And of course, Bermuda grass, which is a perennial grass. So the easiest way to tell the difference between these weed species, especially the grasses when they are small, is to look at what is called the ligule, which happens to be at the point where the leaf blade kind of meets the sheath. So for fall panicum, the ligule will be hairy. It will be a membrane for the crab grasses, a membrane for goose grass, and a membrane for sandbar. And crowfoot grass and Bermuda grass will have hairy ligules. So that's the easiest way that you tell the difference between the grass weed species. So it's very critical that when you go out and scout the field to kind of get to identify these weed species at these stages of growth, because these are the points that when they are way easier to control. And when you control them at these stages, you ensure that they don't flower and produce seed, which become sources of seed for infestation in the subsequent seasons. So this is just a graph here. I don't know if you can see it from the back, that shows the critical period or when you must control weeds in snap-in, and this was based on some study that was done on organic soil. So it's basically the period in which you have to control weeds to minimize any unacceptable yield loss. And a lot of these periods are based on either accepting like a 5% yield loss level or a 10% yield loss level or 2.5% yield loss level. So for the studies that we did here to reduce your chances of getting a 5%, a 2.5% yield loss level, then the level of weed control, you have to control your weeds from the cotyledon or when the bean is at the unifoliate leaf all the way until the R4 stage, which is during the mid pod set. That's when 50% of the pods have been developed. And then to have like, a 5% accept, yield loss level, then your weed control has to start from, the first trifoliate leaf all the way until, the R3 stage, which is the early pod set. So basically what this tells you that if you want to reduce your weed control, your yield loss by between 2.5 to 10%, then for beans, you kind of entirely have to have weed control throughout the entire season for the crop. So yeah. And how would you plan an effective weed management program for snap beans? You want to have something like this instead of a field that is a little bit weedy, the one on the left here. So these are some of the basic fundamental things that you can do. And to develop an effective weed control strategy, some of the things to consider are the weed species that are present, and that goes back to scouting the field to identify the correct weeds that you have. If you're going to cover crops are critical in suppressing weeds if you are not following the crop with anything else. Some of the pre-plant tillage that you might have, herbicide incorporation. There are certain herbicides that can be incorporated for pre-emergence application. Some of them you can incorporate mechanically. I don't think a lot of people do mechanical incorporation here like they do with bean production in other areas in the country where they do a lot of dry bean production. The cultivars, you want cultivars that close the canopy faster. Your choice of row spacing, whether you're doing rotary hoeing, cultivation. This, I mean, mechanical cultivation within the crop, and of course, your choice of herbicides to use. So one of the first things that you have to do, of course, as I've mentioned before, is having an accurate weed identification. And this usually is the most important first step that will result in you having an effective and economical weed control program or treatment choices that you decide to use. And for weed management, it's always ideal to use an integrated approach, use multiple tools. In our area here, mechanical control is pretty common, cultivation. And then, of course, there's cultural control, things like crop rotation or using a cover crop during the fallow period when you're not planting any beans to suppress or reduce chances of getting weeds back into your crop. And of course, all of us use herbicides is typically the main control approach that we use. So integrating or combining all these multiple tools is usually very critical in having a successful weed management program. So here's an example of a snap bean field, after you harvest the crop. So depending on what you want to do next, you always want, during the fallow period to make sure you don't let the field to be, covered with weeds like this. Here's an example. I think this is like a pigweed here. It's already flowering. I mean, as seeds. So this is gonna just give you more problems as you get into the next cropping period of season. And having a fallow field that's relatively weed-free, especially in sandlands. On mark soil, we have issues with subsidence, so you have to kind of figure out how to go about stuff. But trying to keep the fields, disked or using a cover crop to make sure that you don't have any weed species coming in, or the cover crops can help suppress or diminish, limit the ability of weeds to pop up. And then, of course, if you're doing any rotation, one thing with the rotational choices is to make sure any herbicide products that you use in your snap bean will not affect whatever your rotational crop choice. A good example is something like there's a herbicide called Reflex that is commonly used in snap beans. But if you look at the rotational restrictions, sugarcane falls within other crops, which is about 18 months. So those are some things that you have to consider when deciding on the herbicide that you use. So I put a slide here. It's a little bit busy just to show you some of the common herbicides that are used, either pre-emergence or post-emergence for weed control in snap beans. And here are some of the weeds here. And as you can see, something like common lamb squatters, most of the good control you'd get with some of the pre-emergence herbicides. I don't know if anybody uses TREC around here, but Prowl should be a common one. Reflex is also good on common lamb squatters for pre-emergence. For post-emergence options, most of the herbicides that we use around here are not that effective. Nightshades that are very problematic, you can use Pursuit or Reflex. Pre-emergence or for post-emergence, either Pursuit or Reflex, or usually a combination of Pursuit and Bazagran will give you very excellent control of nightshades or the amaranth species. Majority of the pre-emergence products, Dole, Treplan, Pursuit and Reflex are pretty good. And also Pursuit post-emergence or Reflex post-emergence. And Sanjay will give you some good level of control for the amaranth species. And then, for common ragweed, majority, let's see. Yeah, either Bazagran or Reflex, or a combination of Pursuit and Bazagran. That usually is pretty good. For most of the grasses, the products that we have are pretty good on our grasses. I don't know if anyone uses Assure, but if you use Post or Select, those are pretty good for controlling grasses. And if you have nutsedges, you can use Sandia, or if you use a combination of Pursuit and Bazagran, that should give you very good control of something like nutsedges. So hopefully we'll share this slide so that way, because this is a busy slide, something that you can go back and have a look at. So just to summarize here, so as I've mentioned, especially for herbicide use, one of the critical things is to go out, scout the field, identify the weeds, make sure you know what weed species you have, because correct weed ID will help you with selecting the appropriate herbicide or herbicides to use, and then make sure you know what mixtures that would be appropriate. Let's say something like Pursuit plus Bazagran. If you gotta do sequential treatments, look at compatibility. Make sure you put out proper adjuvants with some of the products, depending on what the label says. And then, of course, crop tolerance. And one key important thing with herbicide application or any pesticide application is to make sure that your equipment is properly calibrated, so that way you'll be putting out the right amount of product and to get good efficacy. So just a slide here, for chemical control, make sure you do it right. Get your proper herbicide based on identifying the correct weed species that you have. Proper placement of herbicides. And this goes back to calibration of your spraying equipment, proper timing. Make sure you time the application based on what the label says, because when you miss that window, then you might not get very good efficacy of your product. And then, of course, proper manner of application, which also goes back to proper calibration of your spray equipment. And always read the label. It's important, on things that you have to do with regard to things like rotational restriction and so forth that may impact your subsequent crop. So I think with that, thank you, and I'll give the floor for Ramdas.
Okay, good morning. I'm Ramdas Kanissery. I'm also a weed scientist. I'm located in Southwest Florida Research and Education Center in Immokalee. So I'm gonna do a very short talk, and I'm trying to catch up from where my previous speaker, my good colleague, Dr. Odero, stopped. But I'm gonna focus a little bit more on pre-emergence herbicides, because this is the thing. We are talking about herbicide shortages. There are issues like supply chain problems, rise in cost, and things like that. And we heard from the previous speaker, when it comes to snap beans generally, early to mid-season weed suppression is very important. That is a critical weed management period, right? So I think as a weed scientist, I really believe we should bring in more focus into the pre-emergence program as a pre-plan incorporation and things like that, so that can help you manage your weeds, suppress your weeds, longer time into the season, which is very important, right? So in this talk, what I'm going to do, I'll bring a couple of messages into the table, how we can improve pre-emergence use, and also what are some of the considerations we need to keep in mind, especially when we do bean production in muck soil. And again, we are seeing more bean production in the sandy soils in Southwest Florida as well. So I want to start this talk with this picture, okay? This is a amaranth or pigweed. We already saw that it's one of the popular or widespread weed in beans from Dr. Odero. Look at the size of the thing. So the message I want to bring here, these bad guys can actually suck up all the juice from the soil that should be otherwise available for your beans. I just want to bring that message. They can create a lot of competition for your crop. And again, this is literally a Parthenium. We heard about that, very popular weed in beans. So literally, we found this farm in Immokalee, the whole farm, this is actually a cucumber farm, but it was a whole farm was taken over by this bad guy, Parthenium. So again, when it comes to weeds like Parthenium and the pigweed, it's not just a competition. They can be the source of pests. They can be source of diseases. And in beans, especially when you have Parthenium growing in the row, it's going to interfere with your harvesting and things like that. So this has to go, right? So I'm going to show you some numbers here. These are just large numbers, very big numbers, but it's not just number. This is the number of seeds these weeds can produce per plant. This has been verified by WSSA, Weeds and Society of America. So almost 2 million seeds per parcellane, black nightshade close to 1 million, and 200,000 for pigweed. So it's reality. So these guys, when you have that in your field, it's going to make a big seed bank in your soil. You may not see that today or tomorrow, but it's a ticking time bomb. It's going to come up sometime. So your soil, the 4 inches or 5 inches of the soil, whether it's muck soil or sandy soil, it's a big seed bank. So let's take a look at the purslane. You can see purslane growing in the rows with beans here. So I don't know if you have noticed the purslane, common purslane flowers, very beautiful yellow, yellow flowers. But if you look at that, the flowers will be turned into fruits, and each fruit will pop up and release all these hundreds of thousands of seeds into the soil. And we found that out of these seeds, almost 20% of the seeds are viable. They can stay in the soil. 20%, probably the 80% will be, scavenged or eaten by the bugs and things like that. But this 20% will stay there. And as far as I know, some of these weed seeds are viable for up to 8 years. So again, that brings to the point, taking time bomb, right? So what we have to do? So to me, as a weed scientist, the number one strategy you have to keep in your mind, never let them emerge from seeds or tubers. That should be our number one strategy. And we have an excellent tool in our toolbox for that, pre-emergent herbicides. So again, I'm not going to go into details of what are the herbicides and things like that. Dr. Odero already talked about that. We have several options in beans. To me, it's not that much. We are trying to add more options, but still we have something to play with here. And we have, the rates and everything Dr. Odero talked to you about, and we have more details in our vegetable production guide. But just keep in mind, there are herbicides that are applied directly to the soil. They stay in the soil. Again, the 4 inches of the soil, that's the all drama happening there. That's the weed germination, weed emergence, all weed activity zone. If you cannot keep it there, it's gone, right? And so I want to bring this message again. So when you think about the soil and pre-emergence, the interaction between the herbicide and the soil is very important. Normally, normal production soil, whenever you apply a herbicide, depending on the herbicide properties, depending on the chemistry, the physicochemical properties, etc., the herbicide will bind or get attached to the soil. Could be clay. Clay matter in the soil is a big player there. Organic matter, many herbicides like to stick onto organic matter and stay there. And again, that helps to keep the herbicide in the top 4 inches so that the emerging tubers, as in nutsedge or germinating seeds, can be prevented or suppressed. But what are we dealing with here? This is muck soil, more than 85% organic matter. So this is, and when I think about that, bean production is a challenge at the same time opportunity, because there's a diverse soil we are dealing with in Florida, like muck soil, and in our area, Southwest Florida, is practically beach sand, less than 1% organic matter. So if you think about the muck soil, it's a lot of organic matter grooves, right? So if you apply your pre-emergent herbicide, it's going to stay there for a longer time because there are a lot of organic matter. So this binding makes it temporarily unavailable. And I want you to pay attention to the word temporarily. It will not be available it will not be bioavailable, like in scientific terms, but that means it will not be available for the seed to absorb and get suppressed. But that's why if you look into the labels, most of the pre-emergent labels that we discussed, there is a special statement that in high organic matter soil, go with a higher rate, or they will suggest a higher rate, because you may have to bring that higher rate to get that lethal dose there because it's temporarily inactive. On the other hand, the challenge is different in our area because there is no adsorption or binding sites. Whatever you put, it's going to go from the top 4 inches or weed activity or weed drama zone. So faster herbicide dissipation. So in our area, we are suggesting the growers, the bean growers, utilize some strategies to keep the herbicides in the top 4 inches. For example, we have done a lot of studies recently utilizing tank mixing the herbicides with sticking agents or adsorption agents, and that's helping to keep it in the 4 inches. So faster herbicide dissipation is a problem in sandy soils, okay? But one thing that we are not paying attention here, this sticking or binding of the herbicides in the muck soil or organic matter soil is a temporary phenomenon. At some point of time, it's going to come back to the soil solution. It's going to be again plant available. So that's something we need to keep in mind. What? Persistence is not good for the there can be a lot of carryover issues and things like that. So I just want to bring to the table these points. Pre-emergent herbicides, you have to think about the chemical properties as well as interaction with the soil. It may absorb very well, but at the same time, it's going to come back to the soil solution and cause some carryover issues in the next season as well, right? So I just want to real quick show you some properties of the pre-emergent herbicides that are popularly used in green beans. As you can see, there are water solubilities here, soil absorption capacity, and the movement rating in the soil. So just keep in mind that these herbicides are not behaving equally in the soil. Some herbicides move fast, like halosulfuran or famcefan or imacetapar. But when it comes to dual, treflan, and proud, they can stay more, they can linger more in the soil. Anyways, so just pay attention to the plant back interval. For example, this is a plant back interval for some of these herbicides for beans. It varies from 2 months to 12 months. So again, this changes from time to time. So it's important to pay attention to this plant back interval when you use pre-emergent herbicides in beans. And some materials like metolachlor can stay longer, because we have found that metolachlor has a greater affinity for the organic matter. It's going to stay there forever. So it's very important to check if you have any, there is a high threshold of metolachlor or dual in your soil before planning your bean planting. So in this context, I want to bring in another point, especially this is more or less focused on our Southwest Florida growers. There are many farms coming up there. Some of the citrus lands are being transferred into or transformed into bean production. So this is a picture of a citrus. All the trees are pulled out. And you can still see, after 9 months, you can still see the effects of residual herbicides there. If you look around, the vegetation gives you a lot of hint whether you have higher residues in the soil, because you can see here the weed vegetation is getting brown. That means even after 9 months of application of some of these pre-emergent herbicides, it's there. The effects are there. And one thing I want to bring here, many herbicides that we use in citrus, in tree production, has a longer, it's applied in relatively higher rates than the vegetable crops, so it has a longer residual timeline. So, but if you plan to, if any one of you are interested in transforming a citrus area into a bean production area, generally most of the herbicide that's been used in citrus has a 12 to 24 month residual activity or plant back, rotation or plant back restriction there. So pay attention to that. If it's over 2 years of age, that's okay. You can go ahead and plant your bean. But if it's within that, it's a good idea to do a bioassay. For example, basically it's a simple technique. You collect the soil, you plant some indicator seeds like beans in this case, or maybe squash that's very sensitive to these herbicides. So you will see something like this. In this case here, the soil one is not looking good, right? This is a soil we collected from a citrus land, which is being transferred into a bean production, and you can see the peas, the squashes in this case are not coming out very well because there is some herbicide content in there. So in that case, it's worthy to check it analytically to make sure that particular herbicide or group of herbicides are not present and the land is safe for your bean farming. So again, I just want to bring this message again here. Never let them emerge from seeds or tubers. And there are several techniques we have to deplete this tuber bank or seed bank. Dr. Odero already touched base with this, like fallow field program. I just want to let you know that we have a couple of more tools in the fallow field program other than glyphosate, like Sanjay and Eptam, which are very effective. You let the nutsedge grow. Especially if you have nutsedge pressure, I'm talking about nutsedge pressure here, let it grow, hit it with glyphosate or Sanjay or Eptam. Then again, maybe you have to follow it a couple of times, and that way you can deplete the tubers in the soil. That's the only way to do this. And we have cover crops. I already talked about it. We already talked about it. I just want to show you some examples here with cover crop and without cover crop. The picture tells it. So that's all. So we talked about early season weed suppression, pre-emergence, very important. Think about the soil binding, raids, crop safety, plant back intervals, bioassay, especially for new farm, and weed seed bank suppression is the key here in vegetable production. Thank you very much. This is my team. Thank you. I want to thank them. They do all the work. I just present. That's all. This is a weed garden in our research station.
Thank you. Thank you. Thank you.
All right. Good morning, everyone. I am Haimanote,
but I know it's difficult. And I prefer to go by Jaime because I want everybody to remember me, right? First, I think we're gonna switch gears and we're gonna talk about a little bit about water, which I think is very critical because it affects everything we have been hearing, weed management, nutrient management, everything. So I'm happy to talk about the potentials of variable rate irrigation with the soil moisture feedback system for snap bean production in South Florida. This is actually part of a bigger project we started 2 years ago using funding from USDA NIFA. We are doing a precision irrigation research on snap bean and sweet corn. The idea is to develop irrigation management tools for these two vegetable crops. And today I'll be focusing on snap bean. We have been planting this, this project has been going since 2020, and we have data from 2 years. The cultivar we were growing was Caprice. We planted in 2020 on towards the end of November, and 2021 we planted early December. We have 16 plots under beans 30 feet by 18. When we collect a lot of data, so moisture data, we have UAV system, we collect the percolation, but I will be only talking about the okay. So our objective was to test the plant's response for 4 irrigation treatments, ranging from 25% to 100%. And we use a variable rate technology. Briefly, variable rate technology is fairly new technology. Advanced technology has been tested on growers and research plots and have shown significant benefit, conserving water, nutrient leaching reduction, reduction in chemical leaching, and improving yield and yield quality. What the technology allows you to do is it allows you to apply different rates of irrigation. It allows you to change time, frequency, so on and so forth. And there are 2 major types. One is the speed control. Different irrigation rate is achieved by changing the speed of the machine. High irrigation rates, the machine slows down. Small irrigation rate, the machine speeds up. But one limitation about this is you can only change across the travel path, not across the span. And relatively, the speed control type is cheaper, a couple of $1,000s. And you can get it and you can add it if you have an existing system. The second is zone control. Here you have a group of sprinklers, even sometimes an individual sprinkler put as a zone. And this gives you much more flexibility to control pretty much the amount of water that you apply in every pocket of your field. And it's a little bit expensive, however. So if you look at like having the system, the linear, the center pivot, the big gun, whatever, and then the software, it's just infrastructure, right? Irrigation is a continuous process. We have to manage, we have to fine tune, we have to have a feedback system. And our only objective is to keep our plants happy, right? So we have 3 options, usually. The first is we monitor the weather condition. We monitor rainfall, we monitor temperature extremes and use that information to decide and when to irrigate and how much to irrigate. The other is monitoring the plants themselves. We monitor leaf water potential, crop water stress, and canopy temperature, so on and so forth. And the third is by measuring soil moisture. And today I will focus a little bit on that. We use different sensors to just continuously monitor soil moisture. And when some trigger point is reached, we just send a feedback to our machine and we just irrigate it. For this project, the first thing we did was we wanted to understand our soil first, because that's where you want to put your water. We want to understand what's the optimal soil moisture status, what's the dry status. And then when that refill point is reached, we trigger irrigation. Simply, if we let it continuously dry without irrigation or rainfall, then plants will experience stress. depending on the severity of stress, the length of the stress, then you might end up having a yield loss. For this specific project, we're using Theros 12 soil moisture sensor. It has 3 pins, and a Theros 21. There, like one is volumetric, it measures the volume of water in the soil. The other is tensiometric, it measures the tension of the moisture in the soil. And we have a data logger. If you're interested, I have brought one I can show you. And we collect every 15 minutes. And when soil moisture reaches that critical point, we send information to our machine. But people always think that, oh, you have an automatic system, a soil moisture system that continuously measures data, and good, you are all set. But no, that's not the case, because these things fail sometimes. And this is an example. We put sensors in the replicates, right? If one fails, at least we have a backup. And sometimes you get weird results. This specific sensor, for example, we're not giving accurate results. And if we follow this sensor, that means our soil is extremely dry and we're in trouble. But if we look at other sensors, we are all good. So it's always important to pay attention to the data also, data cleaning, and making sense of out of the data is part of the job as well. And one tip to avoid error data or data issue from your soil moisture sensor is installation. When you install, that's the most critical time that you can make sure you will get at least a good data. Most sensors require a good contact with the soil profile. And one of the challenges that we face with this project, since we have a very deep and nice soil in South Florida, I'm kidding, we have rocky soils. It's really even difficult to put these sensors in the ground. And one solution we came up with, actually it's been done in different places and growers also do that, is we prepare a soil slurry so that we ensure good contact, and that way we were able to get a better soil moisture readings. So at the end of the day, you get different moisture readings in your field. Maybe you have different crops, maybe you have different soil, maybe you have the same plant with different planting date. And let's say, for example, I have 4 management zones. How does this play with the concept of variable rate irrigation? I have one machine. I can only put one number in the control panel, but my field requires 4 different rates, ranging from 0.15 all the way up to 0.6 inches. How can I do that? So if you have that VRI technology, the dealer gives you a software where you can develop a prescription map. I take this information from my soil moisture sensors, and I've developed this map. I'll be happy to walk you through how you can develop these prescription maps. This software is free. So you provide the machine exact lengths, exact widths of your management zones. So the machine has a GPS system in it. You send it online through internet, and the machine will do, it takes this number, the maximum, multiplies by 100%, and this part of your field will get 0.6. It takes this number, multiplies by 25. This part of your field will get 15%. That's the idea of variable rate irrigation. So the first question, does it work? We've been working on 1 acre field on which we have 32 plots, 16 on beans, and another 16 on sweet corn. And the first thing we did, we were also curious ourselves, was we ran the system with irrigation zones in alternate dry and wet alternate. So we ran the system. So if you see, the darker colors are plots that receive water. The light gray colors are plots that stay dry. So pretty much did a good job, right? Except in the wet plots, you see, water outside the plot boundaries. That's just expected because of wind drift and yeah. So it really did a good job. And we were interested to see the application uniformity of a big gun as well. We just ran our big gun for 30 minutes. We have a drone with an infrared sensor. We flew it to see how the moisture distribution looks like in the field. And as you can see, it's not that great for some reason. There was a lot of water being applied here and not that much on this side. I just wanted to show you that so that you can have some idea about the difference between these two systems. And at the end of the 2-year period, the bottom line is yield. As I said, we're testing for irrigation rate from 25 to 100. Surprisingly, yield was not affected by irrigation treatment, right? Interesting. Net marketable yield, the same thing, no difference. We were also measuring plant height from about 2 weeks, 3 weeks after planting all the way until we harvest. And during all time, no difference between the irrigation treatment. That's good because if you look at what it means in terms of water savings, it's a lot of water. Up to 75% water savings from snap-in production based on 2-year data. That translates into, for example, from the 25 treatment, we were able to save about 85,000 gallons of water per acre. Think about that. That's not just water, that's the need to pump. You need to pump that water. Maybe that also might have another benefits, which I will talk in the next slide. But why? Why did that happen? 75 reduction is a lot of number, but why that happened? And intentionally, we designed this experiment to do it during a relatively dry season. We do it during winter because historically, that's the drier season in South Florida. But still, we were getting a lot of rainfall. All the top bar plots are rainfall. All the bottom are our irrigation events. Early stage, we apply about 1/4 inch in every irrigation event. And after that, a little bit under 0.5 inch. And we get quite well distributed rainfall. If I may, there was a little bit extended dry period here, a little bit here. Other than that, they have, rainfall. So we have to always think that irrigation is supposed to supplement rainfall. And when we have enough rainfall, we don't need to irrigate week after week, week after week. But one thing here, if you look at, we ended up irrigating about 1.25 inches. And on January 30th, we had a frost day. That's one limitation of this system because it cannot travel that fast and it cannot cover the entire field. And we ended up putting impact sprinklers because we wanted to save our plants. In summary, we were able to conserve up to 75% of water. We didn't measure nutrient leaching, but it has some implications in nutrient leaching and water quality improvement as well. And if you add all these, as I said, the pumping cost, that saves money. But it's really expensive. We were fortunate enough to get some support from UFIFS to acquire this machine, but it's a little bit expensive. The machine itself, the linear, the tower, and also the VRI technology itself is expensive. For about 225 feet tower, we paid a little bit more than 10,000 to get the VRI technology. And that's a limitation, and I understand. Growers, work within a very small margin of profit, and they cannot afford it. And I hope that some programs like the ECOOP program can assist growers, and that would eventually increase its adoption. And another last disadvantage or maybe challenge with the system is it has a limited mobility from farm to farm. The linear, you can take it from one farm to another farm. If you have a center pivot, it's fixed. But also that mobility, even within one farm, will not allow you to cover all your field at a time. And that makes a little bit challenging when you have frost, for example. And that's why I just showed you earlier, we had to put another irrigation system to protect our plants. With that, I would like to thank my group graduate students, the field crew at TREC and UFIFS research, and USDA for funding, and I think I'm on time.
Perfect, thank you.
It looks like 25 is doing good. And then I didn't show the number. I'm sorry.
25% of what?
We were irrigating based on soil moisture depletion.
Was there a per acre inch number that you came into?
I don't have that in from top of my head, but I can give you that. Yes. Yeah.
We can have more time later for questions. We're gonna go and continue. So our next speaker is Sanjay Shukla from Southwest Florida Research and Education Center. And he's going to talk about water and nutrient management for seepage crops.
Hi, everyone. So there is a lot of pressure on me and Craig to make sure that we don't come between you and the stake. And with Dr. Breeza sitting in the back, he's the boss, so I need to be careful. So if you have a lot of questions, meet me outside. So what I'm going to get started with is focus more on water and nutrient management, just so you know, we are going to have a tag team presentation. And it's all geared towards, a lot of you have heard about the phosphorus recommendations and how IFAS has already, we have received some funding. Some of you, I see Alan, some of you are already, we are already working with some of the growers and Chuck and some of the growers. And so what we want to do is just give you a brief overview of seepage irrigation. Most of you use seepage irrigation. On the beans, anyone using other than seepage irrigation right now? Of all the growers I see? All right, Alan, and anyone else? All right, so I'll just give a quick overview on water table management, and then we'll go into the nutrient and why we are doing what we're doing and how we want to going next year go to the beans. So seepage irrigation with regard to some basics of plant available water, all of you know, field capacity, wilting point, basic concepts, any of you? It's all good? Very good. Next. If you all know that, all right. So seepage irrigation, but all of you are already aware of that. You know, you can have a weed ditch and, you know, basically manage your water table. The key really is, and really on the sands, yeah, you can have some particle size variation, but it's not that you're going to get a 15% clay in South Florida, right? So, but you do have, and what is really important here, if the mouse for some reason is not showing up there, but on the left side here, this is just think of the capillary, you know, all of you have done the high school experiments, or at least should have done that. But, you know, different, the finer the capillary, the larger the water will rise, right? So that's the whole idea about the water table base. You're irrigating from below. So on a finer soil, you'll be able to maintain your water table lower. And so the coarser the soil, you have to maintain your water table higher. So with that, and in this area, 18 to 24 inches where the growers manage overall water table. And that really depends on the soil texture. So some of you, you may have a marl, or you may have some just a bit higher clay content. That does play a big role in where your water table should be in seepage irrigation, because that's the only way you manage your soil moisture. Irrigation. And really high or low or basically just right, you know, that just right as to where that water table should be. You can never be perfect with seepage irrigation. If you just get your water table high, where, you know, at the right area without the rainfall, and that's the best you can do with seepage irrigation. The good thing about seepage irrigation is the overall uniformity. Those of you also, I know some growers with drip irrigation, you know the challenges of making the uniform, especially in the raised bed, uniform soil moisture. Water table fluctuation, that's something which is, especially in South Florida, is something called capillary fringe. So just because when you get water table really close to the surface, for every 1 unit of rainfall input, you get a disproportional increase in water table rise. So we developed this equation, which works most of South Florida 16 times almost. For 1 inch rainfall, you get 16 times water table rise. So that a lot of times it's not very intuitive that, why would you get such a high? Because if your water table is around 24 inches, even some of the higher levels, it's almost saturated. So you don't have much storage. So this is why you get a much higher or disproportional rise in the water table. So the next question is, well, what is the right water table depth? I mean, a lot of growers have, or some of you have experience-based, management of, I'm sorry, hold on one. Experience-based water table management. We did this study actually at Chuck's farm way back. I started, almost a couple of years after I started my career, we started working with wireless soil moisture sensors. And the idea was, can we figure out for, in general, South Florida, where your water table should be? And how do you figure that out? And that would be, the idea was we install the soil moisture sensors, same kind what Craig is also going to talk about, Craig and Anna. I know they are working with some of the growers. And so we worked on different crops. And so I'm just going to show you that we had a soil moisture-based water table management and the conventional system. And as you can see, the soil moisture was, much more into the optimal area compared to the conventional if you're not looking at the soil moisture. And here is the actual water table depth. So you can see, almost sometimes 20 centimeter, 8, 9 centimeter water table difference. Basically, the main idea is that you can use the soil moisture probes, all kinds of soil moisture sensors. And you don't really have to continue to use it if you really don't want to. But for your soil and farm type, once you install a soil moisture and you manage your water table wherever it is, you'll be able to figure out, is that good enough or not? And once you figure that out, there are very inexpensive ways of flag wells, like, float wells. It can just, it's on a float. You'll be able to see that and say, well, my water table is around 22 inches, I'm good. If that's what the water table you need. But the soil moisture sensor, where it can really be helpful, is figuring out that water table depth for you, which sometimes, as you know, those of you who have large seepage farms, field to field, you also have that variation. So that's, this is another study we did, where, as you can see, for the soil moisture based versus the conventional, the water table was, in the optimal area compared to without looking at the soil moisture. And when you have that, you also have a lot more storage capacity in the soil. So the next rainfall comes in, you'll have less runoff to pump out of your farm. And therefore, the water and nutrient losses with that. And with that, that's all I have. 10 minutes.
Thank you. And Craig is going to take over,
yes.
And he's going to talk about the importance of grower extension partnership, how to utilize extension to maximize research goals.
All righty. So, all right, so now we're gonna talk a little bit about grower extension partnerships, and we're gonna keep this nice and short so we can get our steaks before they get overcooked. So basically, how can we growers and extension partner together how can you all utilize us to be able to maximize some of your research goals? So we just heard a bunch about soil moisture sensors. Here's one that I've been using a lot recently, usually just a 2-foot probe that has multiple sensors at multiple depths. And from that, we're able to understand some of these things that they were just talking about. So we have this a statewide extension program with agents that have these probes available. Basically, we generally install them together. We seek to learn together. On our side, we get to better understand a little bit more commercial systems and what that all entails, because some of us that are newer are still trying to understand that. And then we get to explore potential management options to improve our water use as well as potentially nutrient use efficiencies. So this is from some bean fields recently. So what do we look for when we're looking at that? One thing is we're looking at trends. So is it pretty consistent? In this case, it is quite consistent, but trends can sometimes, and so what you don't want to see is a whole lot of variation at lower depths. But obviously with seepage, it's a little bit different. You don't have that coming from above all the time. So the other thing you need to look at is how do these values compare with field capacity? So on this y-axis, they're actually not, it's not all the same y-axis for each of these probes. So they're just kind of stacked. But just to give you some idea for this particular grower, at 22 inches, we're saturated. We're above field capacity. So this 0.75 to 1.2 inches per foot is the water field capacity in sandy soil. So that's obviously a pretty big range. And we can figure out that what it actually is with our soil sensors. Again, then at 18 inches, it was again above, way above field capacity, so it's completely saturated. Those little marks are really just 0.02 of an inch changes. When we got to about 14 inches, then we were about field capacity, still kind of on the high side. Again, those are really small changes. And then it wasn't until we were at 10 inches from the surface of your bed that we were then still near field capacity or just below it. So in this particular case, by using this, we could then say, oh, we actually maybe have our water table pretty high. Let's take out some boards. Let's see if we can reduce it and see if we can still have enough soil moisture through these probes at the depths that we need them during crop growth. All right, so basically, let's partner together with this. Probes are generally around $2,000. There are cost share options available, but like I said, we have these available. So let us know. Anna has a bunch. I have some as well. Our extension agent in Martin County and Manatee County all have them as well. And we can get to them into your fields and learn together. So the other thing that I kind of wanted to talk about is how can we, again, partner together to help maximize your research goals. So one thing that we can do as extension agents is to add value to your trials. We can do it by potentially increasing the sampling that you would, more than what you would typically do for on-farm trials. Obviously, you guys, your trials aren't all you're doing. So we can assist you in that. Sometimes increasing different types of data. That soil moisture sensor was actually put into a trial that was for something else, but it was just to say, okay, well, if we're looking at pathogens, soil pathogens, water moisture plays an important role. So let's put these in and let's learn from it along the way. Sometimes potentially sharing costs in some of this with helping out with grants that we can get. And then also adding statistical analyses. And so that's what I'm going to talk a little bit about now. It's going to get a little bit intense, but we're going to kind of breeze through. And the whole point is we want to make sure that we're drawing correct conclusions as we go to this. So science of experimental design is very rigid. And when statisticians talk about our hypotheses, we actually do it kind of in a backwards way, talking about this null hypothesis. But so we're going to kind of flip it around to say how we usually think about it. Does your treatment work? Green plus, or does it not? And then in this table here, are we actually making the right decisions as we're doing our trials? Is our decisions reflecting what's actually happening? So of course, correct decision is if our treatment is really working and we say that it's working, we accept it. And a correct decision is if our treatment doesn't work and we say from what we see in the field that it doesn't work. Then there's two types of errors. One is called type 1 error. This one is basically a false positive, right? We say that it works when it really doesn't. And why I want to bring this up is because there's kind of a tension between the scientific community and how growers would perceive things. So this is something that scientists can't accept. You can't tell somebody that some treatment is gonna cure their cancer when it really won't, right? So we have to, on the scientific side, we have to minimize this type of error as much as possible. But for growers, it's not necessarily so. It kind of depends on the risk level and how much that particular treatment may cost. And the other thing is on the grower side, you also have continual evaluation. So if you try it and you think it works and you go to implement it again, eventually you're going to see if that treatment really isn't working, eventually you're going to see that, right? And so that's why as we set up experimental designs, this type of error matters more for scientists than it does for growers. And how we define this type of error is basically in our statistical design as we do our analysis. So again, this is something that as extension agents in connecting with the research community, we can assist you with. The other type of error is a type 2 error. So this is a false negative. So this treatment really actually works, but because of something happening in the field, other things happening potentially, we said it doesn't. And this is a whole lot more detrimental to growers. And the reason why it's a lot more detrimental to growers is because you all obviously, you're not doing trials for fun, right? You guys have problems that you are seeking to solve. So if for a researcher, if they had this false negative, they're going on to other research problems. It's not, their bottom line isn't isn't affected by it. Whereas for a grower, obviously it is. And so if you had a treatment that was actually effective, but you missed it, and you're now spending money and time trialing other things, that's opportunity, that's cost that you're losing out on. So for growers, this is the type of error that you want to minimize. And again, this one is not something you can set completely from your statistical analysis. But here's another thing to look at is basically these are an inverse relationship between these two types of errors. All right. So if you choose for this to be as small as possible on the science side, like most science fields do, then there's a greater chance of this other type of error. And so as we go into, as we assist you all in research on your farms, obviously that doesn't really matter as much, right? We want to help you analyze in a way that makes the most sense for you. As we look at this nutrient management research project that we're doing, we need to figure out, we need to have conversations together of what is this balance and what confidence intervals do we need to make sense on the science side to say, yes, this is what recommendations should be, but also make sense on the grower side. So some ways that we can affect this here, the error that is most impactful for you all is we can increase our sample size, selecting the right tests, and basically sampling as much as possible. So again, this brings us back to how can we partner together? Well, we can help you by taking more samples, by trying to understand variability that you see out there, replicating obviously on if we're doing nutrient management recommendations that are going to affect growers statewide, we need to be able to have multiple replications. Your trials generally often aren't that. They can be, but also sometimes we can also just sample to find replicates in some of those trials. And again, the whole thing is we want to make sure that we're avoiding the errors and we're drawing the correct conclusions. So where do all these errors come from? It comes from experimental variability. So there's a variability sometimes in our treatments. So a particular treatment the efficacy of it may vary depending on time, time of year, something like that. Your problem to overcome may vary. So you might have your pests is just insects often, population densities are different in fields. Is your application of your particular treatment actually completely uniform? Or is that causing variability? There's experimental variability in our sampling methods and in errors. And then there's also external things. So we have our soil differences, irrigation differences, all even just within one block, say in snap beans in between your two ditches. There's going to be variabilities there, and proximity of weed hosts for some of our pests and diseases. So this is why in general we replicate to minimize these variability. And again, this can also happen just through sampling to minimize some of this variation. So again, partner with us on extension to access some of our expertise, our equipment, our time. We'll connect with the researchers as well. Partner at the beginning, because setting up this, I was going to get into some examples, but we're going to cut that today. But if we partner at the beginning, we can make sure we set it up well to reduce that variability. Again, consequences are high. The consequence is wasting time and resources.
Those steaks must be really, really good because he just rushed through it. I think Sanjay is going to come up here again, and then with Craig, they are going to talk about a little bit more on research overview on phosphorus research. So, and I don't know how much time you guys have, but. And just a quick question. I know it's not the time, and so he's going to kill me for that. Is anybody growing any cabbage in the area? And or consult on cabbage? Please find me later, because I would like to give you a little survey. Please, it's important. Thank you.
I'm going to go really quickly, but since some of this I'll come later, I did want to tell you that I know the growers have always talked about this probability. So I have been reading up on it, and if those of you are interested, I did find an American Statistical Association, basically a statement, public statement in 2016. They're saying that, and I wanted to make sure I read it to you. The p-value was never intended to be a substitute for scientific reasoning. And that says a lot, meaning that, this 0.05 business is really depends on the risk. What risk are you as a grower willing to take? 95%, confidence 90, 80. But, I mean, what are the kind of risk you take when you farm? How much certainty you have to know what your profit is going to be. So I think that is really important. And the reason I mentioned that, I'll share some of the data. So I'm going to go not spend any more time on that and just tell you that we are finding out that the nutrient in itself doesn't exist. It's a system we are looking into. And I think I'm a firm believer that when you look into any recommendations, you need to look at the system, interaction with water, interaction with disease. So going forward, with regard to all these experiments, we are also looking to pest and disease interactions. So working with pathology, especially, for example, in nematology, we have found the nematodes and phosphorus uptake interaction that we want to look into. Those of you who have, some of you have looked into, we have this new production system which is being implemented throughout North America called compact bed geometry. How many of you have heard of that? Some of you, yes. So the main idea really was to really raise the height of the bed. You know why? Because for that seepage, especially for seepage irrigated system, we have found that it reduces Fusarium, Phytophthora, some of the fungus related diseases. So there is an interaction. And then I wanted to show you, getting into the phosphorus recommendation. Look at this picture. What do you see there? That's your seepage ditch. What do you see? Do you see any growth differences next to the ditch versus in middle? So now think about nutrient availability as well as recommendation. Is that possible that you may not be able to manage that production, optimum production, with the same amount of nitrogen, phosphorus, or potassium, right? It's possible. We found this, actually, we have a USDA experiment going on right now. The proximity to the ditch, actually, we were able to statistically prove that it does affect your yield. And it varies by the season. In fall, you have a ditch bed out producing the center bed, and in the spring, it just reverses. It depends on the water and possibly nutrient. We don't know the nutrient part yet. But the point is, if traditionally, we have most of the time, you look into where we take the yield data. So we'll avoid the buffers, go in the between, right? If you're a 3-row ditch or a 6-row ditch, you're talking about 33 to 66% of your production area, which is impacted by ditch. So you are making evaluating the recommendation for the center, 33% of the area, or the whole field, right? So that should be a factor. That's where the water factors comes in. So I just wanted to share that with you. Of course, we haven't found this for bean. But what I'm saying is that we are finding this for different seepage irrigated crops. And then I wanted to get into, just quickly share the seepage irrigated watermelon study where we compared the industry average with our recommended nutrient. 1 year, normal year, we found no difference in yield. Second year, it was a 1 in 25-year rainfall event, if I remember correctly. We did this experiment in Immokalee. Almost get 2.5 inches rainfall in 1 day, right 2 days before planting. And that's when we found the statistical difference in yield because of the nutrient deficiency. So the point is, your nutrient recommendation has to work across spectrum of different weather patterns. It can't be just for an average year. So that tells you about varying, repeating these experiments in different seasons. Watermelon included, grown in different seasons. If you look into bean, that is also grown in different seasons. This is a drone image we just took, and I'm not going to go in detail, but that tells you, I don't have time to go into the details. You could look into the bush, the width itself, and you will be able to look into beyond and this was a phosphorus experiment. You see some of the wetter areas here and drier areas here. So you have to look into this, the water interaction and disease interaction. And I'm just quickly going to go and share with you what we have done so far. We started these experiments to evaluate the phosphorus recommendation for tomato and potato crops. Some of our grower cooperators, I see Alan is here, are already here. We looked into, and all of this, another thing we heard from all the growers is none of these experiments will be done on IFAS farms. It will be all under commercial conditions, large field trials. We're looking into 5 to 15 acres. So that is relatable to you. We're looking into, for Southwest Florida and Central Florida, 6 commercial tomato farms and 3 potato farms. That's what we're doing the experiment. And again, we are looking into different rates to really figure out what is the optimum rate without going in detail, and we're analyzing for different soil phosphorus. I'm looking at my watch because I need to make sure that I pass it on. I did want to share some preliminary results for you. And I don't think we have found this before any of these experiments. So out of our, so far, 6 experiments, 2 of which we have results for, we did find statistically significant reduction in yield for tomato with 0 rate. Meaning, if you go to look into the recommendation, if it is above 45 pounds, we did find at those 2 farms. So that this is the kind of data we need to go back to the Plant Nutrient Oversight Committee to say, well, look, we have actually found statistical difference in yield. That's what it will take to change some of these recommendations, and we need to continue that. I had a really good kind of way to explain to you some of the things, p-value we were talking about. I'm going to skip all that. Just so you know, there is no statistical difference here, but look at the 0 rate versus the rest of it. Imagine if you were to do this experiment, repeat it 10 years, what will happen? What evidence you don't see, you may find enough evidence, meaning, and we have looked into some of the data. One of the experiments we did 16 replication. It was a lot of work. But if I take 16 replication and reduce it to typical 6 replication, you won't find statistical significance. That's the take-home message as to that it does affect that. And then I am not going to go in. So anyway, we are doing these experiments already with the growers. It's a team effort between here, Gulf Coast and Hastings. Craig, of course, is part of it. And so is Hannah somewhere, yeah. So, and then we are really looking forward to cooperation from you. So we are looking for growers to do our bean experiment where we want to do at least a total of, and I think I am just going to go and tell you what our overall, I'm not even going to go in detail, but just tell you what, if it is here, if not, we are planning on 6 bean sites, 6 bean growers we want to have for our, that's what we have planned for next year. That is in Manatee County, Southwest Florida, Henry, Collier, Glades, and Palm Beach. With that, I will.
All right, so so this is what our discussion is going to be about. Some of that slide that we just skipped through, we might share a little bit of that information to kind of lead into our discussion this afternoon. But so that we can again have our stakes on time, we're going to move forward with Dr. Tom Abreza. He is a Senior Associate Dean of Extension, coming down from Gainesville for us today to share more about this research and what our hope is in IFAS and what our hope is in connecting with you all. So thank you.
All right, I came with no slides and he made me one anyway. Thanks, Craig. I really appreciate the talk about statistics because people are afraid to do that. And you weren't afraid, so that was great. I have 10 minutes. I can knock this out easily in 10 minutes, probably less. First, thanks to Anna and Craig for setting this up. There's a lot of work that goes behind the scenes that our agents do to make something like this happen. And you guys don't get to see that, and they did a great job with it. So thanks for that and appreciate the invite. I think you don't ever see the word Renaissance in the title of a workshop talk. It might be a first, but I was trying to think of a word that really kind of meant what I want to discuss today about what happened in the legislature this year. I have a soil fertility background. I was at Immokalee for 13 years. It was always difficult for us to get, large funding amounts to do some really serious fertilizer rate work or soil fertility nutrient management work. And we managed to, scrape by and do what we could do, but, something extraordinary happened in the legislature this past session. It's not totally buttoned up yet because the governor still has to sign the budget, and we have to survive any kind of veto pens. And we don't think that's going to happen in this case, but the legislature in one of their House bills put a line in there, special appropriation 1480A, $8.76 million to UF-IFAS for fertilizer rate nutrient management work. $8.76 million, non-recurring, spend it in 1 year. If you do well, come back and ask for more next year. So where the heck did that come from? It basically started with Scott Engel, our VP, who was very stakeholder oriented and stakeholder driven. As he's gone around the states talking to growers, they've expressed their concern about some of our recommendations, particularly in light of Senate Bill 712 a couple of years ago, which tied IFAS recommendations directly to the BMPs. And when that bill hit, it kind of woke people up and to really look at what we have and point out to our leadership that a lot of our information has been 20, 30 years old and really hasn't been addressed, in a way to really try to modernize it. And that's where the concern comes. The other person that was very involved with this is Senator Ben Albritton, who's over in DeSoto, Hardy, and part of Polk County, and he took this as one of his emphasis items this past session, and he was able to get this money through and approved by both chambers. We really didn't ask for that much. We would have preferred a lower amount of money, but recurring. you know, because you can't do this work in 1 year. It takes 2, 3, 4, 5 years really to get to the point where you want to be. But, you know, we'll take what we can get. And when we saw the final number of 8.76, that was kind of a wow figure. So now it's up to us to try to figure out what to do with it and spend it wisely and efficiently. And it's going to go through FDACS, Ag and Environmental Services. We have to do a contract with them. And so in the meantime, while we're waiting for the budget to get signed, we've scanned the state for interest of our faculty to get involved with this kind of work. I do want to tell you some of the key words in the proviso language. This is legislative intent. These are the things that that kind of guide what the legislature is thinking that they want us to do. They use the word study, fertilizer rates, normal and economical crop production, recommendations, BMPs, maximum yield and quality, minimizing nutrient inefficiency, and 5 crops: tomato, potato, citrus, corn, and green beans. Green beans are one of the 5 crops that were named in this special appropriation language. And they also say, in any other crop that IFAS thinks needs work, you can go there too. So, you know, we've gathered some interest across the state and kind of zeroing in on some proposed projects. Dr. Shukla is involved deeply in this, as he was explaining before, about how to spend this money, equipment and projects that we can get done in the next fiscal year, which starts July 1 to next June 30th. And so it's a scramble, but it's kind of exciting at the same time because, like I said, this is really, I've been with IFAS for 33 years. I've never seen, you know, this kind of money, you know, being able to come, you know, from the government for this kind of research. So we're very fortunate and very happy that this is happening. So our proposals are going to do about mid-May, and then we're going to go from there and then start working with FDACS on a contract. So we've got projects from West Florida, REC, you know, out near the end of the Panhandle, all the way down to Homestead and everywhere in between. It's not too hard to burn up the 8 million when you have so many people interested and so really good projects out there. And we're really, as Sanjay said, emphasizing our people work on growers' fields, you know, and not in research plots behind the center, although we may have some of those going on as well. But growers' fields, that's what the legislature wants as well. So I think I'm going to quit at this point. And I'll be around next few hours if anybody has any questions about it. But I'm really optimistic, and I'm glad to be able to talk to you guys about it. So. Okay.
Thank you, Tom. All right, so we've got a few minutes before stakes are going to be ready. Can you guys start passing this out? So for CCA and CEU credits, we're just going to kind of put one on every single table, or one on per row. I'm not sure how many we have. So you can just scan this with your phone, and then there'll be a quick evaluation survey, and you can put your license number in there, and then we will do all the submission for you, so you don't have to worry about that. But you can do that now. You can do it during lunch to be able to get your CCA and your CEU credits. So as we dismiss in a minute for lunch, we're going to go out the doors, take a sharp left and go through the kitchen. And we'll go to the grill there for our steaks, and then circle back around through the front doors to get the rest of the food as well as drinks. Then again, we'll kind of wrap up lunch maybe 5 to 1, and we'll start our BMP discussion, give a little bit more oversight at that time of kind of some of the things we're thinking, and then we'd like to have good feedback. Again, that's really geared towards the growers. I think we're not going to necessarily kick anyone else out. We're definitely not going to be recording any of that discussion. That's just a confidential discussion we want to have. But for those who are not growers, we like for the growers to come up towards the front. Everyone else sit a little behind and be willing to just kind of sit and observe and listen. So thank you all again for coming to the Snap Bean conference. Hopefully it was worth your time. And again, we hope this discussion will be really fruitful, setting up plans for the next season and this legislative funded research.